all the students. So our today's video is also a continuation of our previous two videos where we studied example networks. By now we have studied ARPANET, NSFNet, X.25 and frame relay. And today the example network that we are going to study is your ATM network, also known as asynchronous transfer mode. The ATM or the asynchronous transfer mode was launched in the early 1990s. The connection that is used in an ATM network is known as a virtual circuit. So the connections are known here as virtual circuits. The ATM network provides you with connection-oriented network. And in order to send a data, you need to set up a connection. So setting up a connection is required when you want to send data using an ATM network. So to set up a network, first of all, a packet is sent so that you can initiate the connection setup. The receiver must know that this is the sender who wants to start sending the data. So for that purpose, first of all, a packet is sent to initiate the connection setup. After that packet has been sent, and while that packet makes its way through the subnet, all the routers on the path make an entry in their internal routing tables. So internal routing tables are those tables which the routers use to see that which path should be used for which particular connection. So when they encounter a new packet, they make an entry for that particular connection in their internal tables, noting the existing of the connection. They get to know, okay, this is a packet which is being sent to initiate connection setup. That means we are going to have a new connection soon. So they note the existence of the connection the moment they see that packet. And then they reserve whatever resources are available for that particular connection. The connections, as I said here, are called virtual circuits. So in the ATM network, throughout, the connections will be called as virtual circuits. Now, most of the ATMs support permanent virtual circuits. Though they can have temporary virtual circuits, but most of them support permanent virtual circuits. Each connection, whether it is temporary or permanent, has a unique connection identifier. Because in an ATM network, you can have n number of connections, right? So how do we identify one connection from the another, or how do we distinguish one connection from the another? This is with the help of a unique connection identifier. Just like in a class, there are so many students, and how do you identify these students? With the help of their roll numbers. Similarly here, each connection is distinguished from the other by providing a unique connection identifier to that connection. Now, once the connection has been established, either side or both the parties can now begin transmitting. So all that you need to transmit data is connection establishment, and once that connection has been established, both the sides can start transmitting. The ATM networks transmit data in small fixed size packets which are known as cells. So one thing here to note is that, of course, the data is sent in small sized packets, but the size of all the packets is fixed. You cannot have variable size packets. Like you cannot say that one packet would be of this particular size and the other packet would be larger or smaller. All the packets need to be of the same size, hence small fixed size packets. And these packets are called cells. So just like an ATM connection is called virtual circuit, the ATM data packets are called cells. To give you an overview or a visualization of the virtual circuit, there is a sending host on one side and there is a sending process in the sending host. Similarly, there is a receiving host on the other side and there is a receiving process inside the receiving host. Now this tunnel kind of a thing that you see is the actual virtual circuit that we are talking about. This is nothing but the communication channel through which the data would be transmitted. And these small rectangular kind of things that you can see are the cells. So these are small fixed size cells that are being transmitted through this communication channel, and this communication channel is what I call the virtual circuit. So through the subnet, as you can see, there are routers and there are transmission lines. So these packets through the channel go through the subnet, wherein they are forwarded with the help of the routers using appropriate outgoing transmission lines so that they can be sent to the receiving host. Now if I talk of the cells, the 53 bytes are reserved for the cells. That means the cell can be 53 bytes long. Out of these 53 bytes, 5 bytes are reserved for the header and 48 bytes are reserved for the payload. Usually header consists of the control information and the payload consists of the actual data that has to be sent. Now as I said that 53 bytes are reserved for the cell, or a cell can be 53 bytes long, and out of that 5 bytes are for header and 48 bytes are for the payload. So the header also consists of the connection identifier. The connection identifier, as I said, is the unique number that helps all the intermediate routers and the receiving host know that which cell belongs to which particular connection, so that when the intermediate routers receive a cell or the receiving host receives a cell, they can easily know that this cell belongs to this particular connection with the help of the connection identifier that is attached in the header field of that cell. Using the ATM network, one incoming cell can be copied to multiple output lines. So this is the concept of broadcasting, that one incoming data can be copied and then be sent to multiple output lines. Now this is the property that is required for handling broadcasting, and usually broadcasting is used in case of television programs wherein you broadcast one channel to many receivers. Small cells do not block any line. This is the advantage of an ATM network, since it sends data in the form of small cells. So if these cells are small, it is quite obvious that even if they block a line or a communication channel, they would not block it for a long period of time. Just like assume there is a narrow lane, and if a car passes by that lane and if it gets stuck, so it is quite obvious that it will take longer to leave that lane. So the lane would be occupied for a longer period of time if a car is stuck there. But if a bicycle is stuck in the lane, it would not take longer period of time to go through that lane. So similar is the case here. You can think of your cells as vehicles and the channel as a lane. So that means even if these cells get stuck in your communication channel or the communication line, they would not block them for a longer period of time. Simple reason that they are smaller in size, so in that way they would get through that particular line in a faster period of time. So this makes quality of service easier. You can easily provide quality of service because no channel or line would be blocked for a longer period of time, which is what is required because the cells are smaller in size. All cells follow the same route to destination. So the cells are not free to follow any independent route of their choice. Once a particular route has been chosen for one cell, then all the remaining cells will also follow the same route to the destination. The advantage of following the same route to destination is that even if cell delivery is not guaranteed, but their order is. Right? Say for example, cell 1 is sent first and cell 2 is sent second. So in that case, at the receiver's end also you will receive cell 1 first and cell 2 in the second number. So the same order in which the cells have been sent, they will be received in the same order at the receiver's end also. So it will be never out of order. Now, if you compare this thing with an internet, in an internet also packets can be lost, but at the same time they can be out of order also. That is, if you have sent packet number 1 first and packet number 2 after that, so there is a possibility that at the receiver's end in the internet, you may receive packet number 2 first and packet number 1 after that. But in case of an ATM network, this would never happen. That means you would receive these cells in the same order in which they were sent, and they would never be out of order. Now let's look at the ATM reference model. Now basically the ATM reference model is a 3-dimensional model. The ATM networks follow their own reference model, just like you have the OSI and the TCP/IP reference model which the internet follows. The ATM network follows its own reference model, right? It is a 3-dimensional model, but if I look in a general overview of this ATM reference model, there are 3 basic layers: the physical layer, the ATM layer, and the adaptation layer, right? And if I give you a 3-dimensional view of the ATM reference model, it would be like this. So see, this is a general overview which consists of the physical layer, then the ATM layer, and then the ATM adaptation layer, which is also known as AAL. And if I give you a 3D view of the ATM reference model, this is how it looks. It starts with the physical layer. Physical layer is further subdivided into 2 sublayers, which is the TC and the PMD. Now TC is the transmission control sublayer, convergence sublayer, and PMD is the physical medium sublayer. So the physical layer is further divided into 2 sublayers known as the transmission convergence sublayer and the physical medium sublayer. TC stands for transmission convergence sublayer. PMD stands for physical medium sublayer, right? Moving on, you have the ATM layer. There are no sublayers over here. Then the ATM adaptation layer or the AAA layer. This is further divided into 2 sublayers, the CS and the SAR sublayer. The CS layer is known as the convergence sublayer, and the SAR sublayer is the segmentation and reassembly sublayer, right? So when we move on, then there are upper layers. These are the upper layers in the another plane. So you have the control plane, then you have the user plane. Above that you have the layer management and plane management. Now let's look at all these layers in detail. To begin with, we start with the physical layer. Now the physical layer deals with the physical medium or the communication channel. So that means it basically deals with how many voltages would you use for transmitting a bit, how many voltages would be used for a 0 bit, or how many voltages would be used for a 1 bit. Then what would be the bit timings and such other issues. Then if you talk of the ATM layer, ATM layer deals with cells and cell transport, right? So it is basically dealing with the format of the cell and the transportation of the cell. So it defines the format of a cell or the layout of a cell and what header means. That means what all information would be kept in a header. This is decided by the ATM layer. This layer also deals with the establishment and release of virtual circuits or the connection that you call. So how and when the connection will be established and how and when that particular connection will be released, this is taken care of by the ATM layer. So basically it deals with the layout or format of the cell and what information would be kept inside the header. It also deals with the establishment and release of a virtual circuits or the connection of an ATM network. Further, the ATM layer also deals with the congestion control. Now, if I talk of the ATM adaptation layer, ATM adaptation layer or the AAL that you call, it allows users to send packets larger than a cell, right? Now obviously a user may have packets which would be larger than the size of a cell. So what does that mean? That user cannot send his data? No. That user can send that data, and that is with the help of the ATM adaptation layer. So what the ATM adaptation layer does is that when a user has packets which are larger than a cell, it segments those packets into size of a cell, right? And then these cells are transmitted individually. And further, at the receiver's end, these cells would be reassembled. So ATM reference model, as I told you, is three-dimensional, and I've shown you the three-dimensional view of the ATM reference model also. Now, if I look at the ATM adaptation layer, then the ATM adaptation layer, as I said, is further divided into two sublayers, which is the CS or the convergence sublayer and the SAR or the segmentation and reassembly sublayer. So what are these two layers doing? These two layers, out of these two layers, the CS layer or the convergence sublayer is providing an interface to the layers above it, right? So when a layer has to communicate with the layer above it, this interface is provided by the convergence sublayer. So basically it makes possible to have ATM system offer different services to different applications. Now different applications may have different requirements. One may want file transfer, other may want video on demand. So all this is made possible with the help of the CS layer or the convergence sublayer. Then if I look at this SAR or the segmentation and reassembly sublayer, it is quite obvious from the name that it helps in segmenting the packets into cells and then helps to reassemble those cells at the destination. So this is the task of the SAR sublayer in the ATM adaptation layer. Physical layer, again, as I said, was further divided into two sublayers, TC and PMD. TC here is known as your transmission convergence sublayer, and PMD is known as the physical medium sublayer. So the task of the transmission convergence sublayer is that it helps to send the cells as strings of bits to the PMD sublayer. So what the transmission convergence layer does, it sends the cells as bits. To which layer? To the PMD, that is physical medium sublayer. And what does the PMD sublayer do? When it receives these bits from the transmission convergence sublayer, it converts this bit stream to cell stream for the ATM layer which is above it. So it converts those bit streams to the cell streams and then it sends to the ATM layer above it. So basically, as I said, the physical layer deals with the physical medium. It directly deals with the physical medium through which the data is being transmitted. So when a data is transmitted, it is converted into bits. So these bits are then sent to the PMD layer. So when data is sent through the inputted through the input medium, it is received by the transmission convergence sublayer. And this transmission convergence sublayer sends that string of bits to the PMD or the physical medium sublayer. And this physical medium sublayer then converts this bit stream to the cell streams so that it can send it to the ATM layer in a format which is understandable by the ATM network. So this was about the ATM adaptation layer sublayers and the physical layer sublayers. Now look at the layers in the other plane. This is first of all your user plane we will see. The user plane deals with the data transport, flow control and error correction. Data transport is basically transporting the data through the physical medium. If I talk of flow control is helps in controlling to swamp a slow receiver by a fast sender. So both the sender and receiver must be at the same pace while sending and receiving the data. So this is taken care of by the flow control mechanism. Further, it deals with error correction. In case there is an error in the data, that means the data is not in the same form in which it was sent. So that is first of all identified or detected by this plane. Then then it is corrected and then retransmitted. So error correction is the task of user plane. So basically the user plane deals with three important things: data transport, flow control, and error correction. Now next is the control plane. It deals with connection management. What does connection management basically mean? Establishment and release of the connection is taken care by the control plane. Then if I look at the layer plane and the layer and plane management, that means they are responsible for the resource management and inter-layer coordination. When a connection is established, you need some resources for that connection. So it is the job of the layer and plane management to reserve resources for that connection. For the communication between layers, two layers, how do they coordinate or communicate, is also taken care of by the layer and plane management. So we can say that the layer and plane management deal in resource management and interlayer coordination.